This lesson describes the fundamentals of inheritance. Inheritance is the basis of all object-oriented programming. While this lesson describes inheritance in terms of Java classes, the same basic concepts apply to all modern programming languages. It's all based on classes and objects. As an example, let's start with a class that is so simple it's pretty useless. The class named Figure has one data item and one method. All you can do with an object of this class is to call the getArea method and have it return the value of area, and the value will always be 0. Notice that the area variable is declared outside of a method, which makes it accessible to every method in the class. You could add a bunch of methods to this class and have them all read or write area information. But we're not going to do that. We're going to do something else with it. By extending the Figure class into a new class called Square, we're able to get everything that the Figure class has and add some things to it. That is, we extend the Figure class and add some data and some methods to create a new class called Square. Notice that this class adds a new data item named Side to hold the length of a side of the square. The method getSide can be called to return the length of a side, and the method setSide can be called to change the length of a side. Notice also that in setSide, the value of the area is updated to contain the area of the square. The variable named area is inherited from the Figure class. The getArea method is also inherited. Let me show you. This class has a main method, so it can be run from the command line. To begin with, it creates a square object and sets the sides to 250. The length of the sides and the area of the square are printed. Notice that the call to getArea doesn't require anything special. It's right there in the Square class because it was inherited from the Figure class. You can think of a class definition as a blueprint, and you can think of an object as something that is built from the blueprint. For example, once you have a working blueprint of a house, you can build lots of houses from the same plan. That's the same principle as classes and objects. Here is the construction of another square object from the Square class. Once you've written a class, you can create as many objects as you like. This one has its side set to 17, and the program displays each side and the area of the square. When you run the program, it looks like this. Now here is another class that extends the Figure class. This is the Circle class. It can extend the Figure class because a circle also has an area. To make it a circle, however, it was necessary to add a data item to hold the radius of the circle. This implies the addition of a getRadius method, and it's a simple matter to add a getDiameter method. The setRadius method updates the radius value and then updates the inherited area value to match it. Now we have our Circle class, and we can create objects from it. For example, this class has a main method that creates a circle object and sets its radius to 100, then displays its radius, diameter, and area. When you run the program, the output looks like this. Now this could go on and on. We could make rectangles, pentagons, triangles, hexagoogleton, or anything else we can imagine. The point is, we have a class that can be used as the basis of construction of other classes. Of course, most base classes have more to them than this simple example, but you can see how it works. You can imagine a situation where a base class is complicated enough that extending it to make new classes would save a lot of work. The class being extended is called the base class or the superclass. The class doing the extending is usually called the subclass. Sometimes the process of extending a class is called subclassing. This whole process is what is known in object-oriented programming talk as inheritance, because the subclass always inherits the goodies defined in the superclass. Just about everything in object-oriented programming is the bookkeeping that goes along with creating subclasses from superclasses. Inheritance is the key to all the mysteries. Once you have inheritance clear in your mind, the rest of the mysteries are trivial. We'll be going into constructors and polymorphism, but it's all just bookkeeping that goes along with the same stuff.